Simpson 260 XLP calibration. Let me show you my setup here. I got a 12-volt supply feeding a 1 to 30 volt regulated supply. Of course, it's not going to go up to 30 volts. Only need it to go up to just barely over 5 volts. I got a 100K resistor here in series with the circuit. This is for the 50 microamp calibration, by the way. So I've got the selector set to the 25 volt 50 microamp position, and I got my leads in the negative common and the positive 50 microamp connection there. Now I'm measuring voltage with this hand tech here, and as you can see, I've got it's just paralleled with the voltage that's going into the circuit. Just measuring the voltage across the meter, and then in series I have the current. I have this set up for current. So now the procedure is to set the current first, and so let me turn this on here. I've already dialed this in, so the way I'm dialing in the current is, with the regulated supply. Let me get this screwdriver on here. Come on. Shaky hands. So we just crank that up to 50 microamps. I know it's set on milliamps, but it's reading microamps. We don't want 50 milliamps. We'd be way out of the ballpark if we did that. We might be destroying something. So well, that's close. Went a little bit too far, but you get the idea. Dial in the 50 microamps first. I need my glasses. That's going to be close enough for me. Now, the first thing you want to do is set this needle to full scale. It's kind of waving around. I think this broken bezel here is allowing a little wind to come in. You set this full scale with R1. Let me take this back off here. Whoops. I just tripped it. So R1 is this right here, this variable resistor. That's directly across the meter, so that's going to set the full scale. And this right here is R3. That's going to set our voltage across the circuit to 250 millivolts. But the first thing we want to do, and we'll play with this here. Let's reset that. Now I'm going to put my hand on the on the full scale resistor and play around with it. It's not really going to affect our current draw. But you see, I'm slowly turning that up so that it reads full scale. And we're still at 50 microamps, but we're drawing 252 millivolts. So now we're full scale. So we want to, oh, goodbye. We want to adjust R 3, 4. I don't know if I could do that with my hands. Maybe I can. R3, 4, 250 millivolts, and that's about right. I'm going to say that's good. We're drawing a little bit too much current there, but you get the idea. Now the other variable resistors are for like your low power scale, and I'll make another video about that as soon as I study up on that. I'm going to provide a link for the schematic and for the military bulletin that gives you an idea on how to calibrate this. Of course, they use something different. They use some precision laboratory stuff, but this you could get by if you've got a meter that will measure microamps, which this for NERSI, however you pronounce that, DMT 99 does. I like that little meter. And then you got another meter that's fairly accurate to measure the voltage at the same time. Then you probably do a good enough job of calibrating these old meters. But I thought I'd share that, give you a follow-up on this meter, so you could see this board cleaned up really good after dipping that in vinegar overnight and washing it off with some dish soap and water, letting it dry for a day, and then spraying the switches with deox and the pot with deox. I pretty much just doused it. Shame on me for my barbaric actions, but I did what I did. But yeah, that's how I did it. If you've got a nice variable supply, then you can probably do a better job than me. But I'm just dealing with what I got here. Yeah, that's that little $7 Chinese variable supply board did a good job. You're only going to need about 5 1/4 volts for this setup here with that. Be sure to put that 100K resistor in there, so you don't overwhelm the circuit with too much voltage and current. But if you do the math, at 5 1/4 volts with your 100K plus your, what is it, about 5K, 5,000 ohms in there, that's what the total circuit of your meter should be. 5,000 ohms and drawing 50 amps of current at full scale. Then this meter's calibrated. I don't, this meter's, I'm not going to use it for any precision type work. Really, these meters, this DMT 99 is just fine for the kind of work I do. But You know, if you want to get this thing within, you know, a reasonable specification for as old as it is, that's good enough. I think I'm gonna actually go ahead and buy another bezel for this, since I've done so much work to this. But there it is. My next video, I'll get to the low power calibration, and I don't know if I'm gonna do the like the AC you know, high voltage calibration, because that might be a liability issue on my part. I don't want to steer people toward the high voltage venture and end up persuading somebody to get too dangerous. So, but I'll provide the bulletin, and you can do that stuff at your own risk, but not on my watch. I'll do the low voltage stuff, but not the high voltage stuff. Too risky. So that's it. Hope that helps you, and I'll see you next time with the low power calibration.